Okay, so as we look at the vertical line test here in ALEKS College Algebra, we'll be doing basically the same thing as we did up here in our dog show test. Let's review quickly. Notice here that our dog show is this high class type of pairing up between masters and dogs that does not allow monopoly. So we cannot have one master that shows two dogs. Likewise, if we were to list these as ordered pairs, we would never allow ordered pairs in a set of numbers to have two first elements the same. So a 4 here and a 4 here would be outlawed. If we were to graph these so that our domain numbers were down here and our range numbers were over here, notice what would happen here if we had a value in the domain of 4, okay, that was matched up with range values of, say, 53 here and 54. Notice that master number 4 would be trying to show two dogs, and in the graph of that then, notice how these two dots would be aligned one above the other. And so we make a rule. We say that if we express then our relationship as a graph with our domain set on the horizontal axis, our range set on the y-axis, we will never allow 2 points to be one above the other. Now, this can happen even if you have lots and lots of points. So, for example, over here someplace, if we were to have a function that somehow looked like this, that was enough points to make a solid line, we would immediately say, no, this cannot be a function because a vertical line will connect 2 points that are directly above each other, and of course that is illegal because we'll have a single value of our domain down here matched with two values from the range. So we never allow one dot to be directly above the other, either in a graph that's a series of single points or if it is a continuous line. Let's go over here in ALEKS and take a look at some problems like that. And let's look at our first situation. Do you see any dots directly above each other here? And we say no. So this is a function. Look at this situation up right here. A vertical line through there will cut the graph twice. In fact, we can put it in lots of places and see that. That is not a function. This one here, definitely not a function. A line vertical here will cut the graph in two places. So this is not a function. What about this one? Now let's look here. What about here? Well, no. Notice here that at this point, this dot is solid, but this dot is open. There is no dot there. And so at this point, there is only one functional value, only one value of the range. What about over here? There's a gap here, and there's a gap here, but we don't have any problem with this being a function. There's just some areas in here for which the function isn't defined. That's okay. It's a function. Okay, what about here? Well, once again, we're okay here because remember, a vertical line can cut down through here at only one place. Okay, not a problem. Here, though, look, up, two dots right above the other. Here, two dots, one above the other. This is not a function. Okay, and so once again, we take this idea of the definition of a function and apply it in a graphical situation. We're good here. Do we need to see that again? Let's do one more. Okay, well, right here, three dots vertically in a row. That's bad, not a function. Here, cut down through there, vertical line, we'll cut it twice, not a function. Circle, cut it vertically, going to cut it twice, not a function. Over here, look carefully. Any dots directly above each other? No, no. Every dot is such that no two dots are aligned vertically. This is a function. What about here? Watch these interlap points. But no, look. See here? That's a dot there, but there's no dot directly below it. We're good. Here, we're good. This is a function. And here, look at this one. It's a straight line. It's a function. In fact, we call this a linear function. Notice that any vertical line that you draw in here will only cut through the graph one time. This is a function. Okay? And that's the vertical line test for functions.